There are quite a few examples of magic strings or values in this code. The first one is the use of the connection string being hard-coded throughout the code. Obviously, this is not a good practice and something that we should move to a more secure location, perhaps, and in any event, a single location that defines our connection strings for this application. Formatting strings are also specified in many different locations, as well as these blocks of for each logic to dump things to the console. If at some point we want to change how this data is formatted, or if we wanted to change where it's being displayed, these would need to be updated in many different locations. Another section is using magic numbers. In this case, the number 1 is specified in multiple locations here without any indicator of why it is significant. And again, there's the use of formatting strings here that are repeated in multiple locations. Let's look at how we can apply dry to remove magic strings. We're going to look at applying the dry principle to remove some magic strings and values from our application. We've analyzed it and found that we have a number of cases where we're setting this connection string over and over in our code. We'd like to move that to a single unambiguous location that defines the connection string for the application. One option would be to move this to connection strings. We would do this by adding configuration manager, which we'll have to add a reference to. So we'll add a reference to .NET system.configuration. And configuration manager has a connection string section where we could specify a name for this. We'll call it the main connection string. Connection string. Now, in order for this to work, we'll also need to add a new app config value. And within our app config, we'll add a connection string section with a new connection string. We'll paste in the actual connection string we're using. And we'll also give it a name. By doing that, we can delete this one here and run our code since we have no actual tests. And if it still seems to work, then we can be confident that that's working. However, if we go through and add this logic that specifies the use of configuration manager everywhere that we're using a connection string in this code, we'll simply have changed one kind of duplication in exchange for another, because now if we later decide to change what that name of that value is for main, or if we decide to use a different method of storing the connection string or passing it into this method, we're going to have to change this in many different locations. So we've improved where the value of the connection string is stored. That's no longer repeated. It's only in one place here. But we haven't gotten rid of the repetition in how we get to that connection string. We can do that by simply pulling that method up to a class level variable. So we'll say string connection string equals this value. And we'll replace this with this. And now there's a refactoring that we can use here where we can introduce this as a field called underscore connection string. And now we're using that underscore connection string field. And if we move this initialization code up here to the beginning of our main method, we can then use underscore connection string throughout for all of our connection strings. I think that's all of them. So now if we run the code again, it should still work, and it does. And at this point, we can see that we've pulled out a fair bit of repetition into this one line that now aggregates all of that information in one place. Another thing that we saw when we analyzed our code was the frequent use of two things, one being this console write line, another being the use of this format string. And in fact, this entire for each loop is somewhat repetitive. As you can see, we're doing it both for our invoice table here, as well as down here for our employee table. We could apply an extract method refactoring in order to pull this data out and give us a common way to write it out. If we want to pull out this logic for writing out a number of rows inside of a data table, rather than working at the row level, we can simply create a new method that takes in the table and dumps out the results using this kind of format. We'll start off by creating this new method. And at this point, we simply want to take the logic we had before, for instance, this for each loop, and convert it so that it's using our table. However, we want it to work over the number of columns that the table has. So we'll do something like this. We've added in a bit of logic here that will determine what the total number of columns is, and then loop through those columns, adding in the row with that column index, and then a hyphen between each one, and finally a right line at the end if we don't have any more columns. This will dump out all of the columns in the table. If we want to actually limit this, because for instance our actual usage up here is perhaps only showing a certain number of columns, 3, even though it's selecting all the columns in the table, we can pass in a column count. So int columns to display, let's say, and we'll use that here in place of column count. So instead of just table.columns.count, we'll say it's going to be that, but if columns to display is greater than 0 and less than column count, we'll say column count equals columns to display. And then we can delete this old console write line that we had before and use our output table method now in place of these locations here. So we'll say output table, and we'll pass in invoice table, which we want to show 3 columns. And we can have our columns to display have a default value if we want to, so we'll make that 0 equals 0. And that'll let us pass in nothing for it when we use it down here for our employee table. Now if we run this, it hopefully will still work. And it does, and if we scroll way to the top, well, we'll have to turn off some of our logging here to make this easier. Let's just do our load and run to show. These are all the invoices being output. And at the end, these are our customers, or our employees rather. So you can see it is still working the way it did before. We have our hyphen separated columns. The next magic value that we had in our application appeared in our transform section, where we're doing these if statement checks, and we're checking whether the count was greater than 0, and then we're grabbing the first item. And if the count was greater than 1, then we're going to grab the second item, which has index 1. And this number 1 here is the same as this number 1 here and this number 1 over here. And so we could do a simple change to say something. Obviously we could fix this in several ways, but the simplest change here to remove that magic number is to have something like int index, which we'll set to 1, and then replace those 1s with our index value. Now if we need to change that, even if it's a copy paste change, we won't forget one of those 1s when we do it down here, and we have these 2s instead. We'll see how we can clean up those if statements in a separate refactoring. Then the other thing that we have here is a format string. This is for formatting numeric values, decimals in this case. If we want to pull that out, it would simply be a matter of creating a new value. We could create it here, for instance. And then anywhere we want to display that decimal format string, or we want to use it rather, we would just replace it here, and here, and here, with that format string. Alternately, this method of doing this write line could be extracted out into its own method. In fact, this entire chunk of if logic could be extracted into its own method or its own separate loop that does this work. But again, that's a separate exercise. So at the moment, we've pulled out a number of magic strings. We've eliminated the connection string duplication. We've shown how we can output an entire table rather than having repeated loops for displaying rows. We could apply that same logic in other places in our code where we're doing looping and doing output to the console. And lastly, we've looked at some display format strings and shown how we can easily replace those with a variable in our application.